Hey folks, so this is a video about the cosecant parent graph. Just a couple of reminders about what we did in the last section when we dealt with sine and cosine parent graphs. The cosecant parent also has an amplitude that is the absolute value of A. It also has a period that is 2 pi over B. The phase shift is still going to be D, and the vertical translation or the vertical shift is still going to be C. So there's nothing different about any of the four formulas that we used back in sine and cosine. We're going to use those exact same ones for secant and for cosecant. I do have a note here that it says always draw only one period of sine, cosine, secant, and cosecant graphs unless you're told otherwise. So that is going to be the normal for tests. So one period of all four of those. Now, in order to get the cosecant parent, what we're going to do is we're going to use the sine graph first of all, and our sine graph is going to help us to get the 5 major values. So you'll notice down on this graph that I have started out with my 5 sine major values. I've already mapped out the period of this going out to 2 pi. The sine graph starts at the origin. Beginning, middle, and end are all on x-intercepts, and the first quarter is a maximum, the other quarter is a minimum. So these are all things that we did in the last section. Now, let me remind you of the fact that cosecant is the same thing as 1 over sine, and we all know that anytime you have a variable on bottom, we have to be watchful, careful about there being a 0 on bottom. So what I want you to think about is I want you to think about the unit circle. And I want you to ask yourself, on the unit circle, where is my sine value equal to 0? Did you find all of the places on your unit circle where the sine value is equal to 0? Now you should have found 3 places on the unit circle. You should have started at 0, sine of 0 is 0. Then you get to the other side of the circle, sine of pi. And then lastly, back to 2 pi, sine of 2 pi is also equal to 0. And you'll notice that on my graph, those also happen to be the 3 places where my sine graph has an x-intercept. So here's the deal. Anytime you have an x-intercept on your sine graph, you're going to have what's called an asymptote on your cosecant graph. If you'll think back to college algebra, anytime you had a 0 on bottom, this is going to draw an asymptote. So if you remember correctly, an asymptote is drawn with a dotted line. So wherever sine had an x-intercept, cosecant is going to have a vertical asymptote. The next thing about my cosecant graph is that the maximum of sine is always going to be the minimum of my cosecant. So you'll notice over here, this is my maximum of my sine graph. It was at the top of my sine graph, but it's going to be at the bottom of my cosecant graph. Now remember what an asymptote is. This is a guy that I'm always getting closer and closer and closer to it, but I'm never actually reaching it. So this is what the first part of my cosecant graph looks like. The next piece is that the minimum of my sine graph is going to turn into the maximum of my cosecant graph. So you'll notice here, this is the minimum of my sine graph. It was at the bottom of my sine graph. Now it's going to turn into the top of my cosecant graph. And this is one full period of the cosecant parent.